Hello and welcome. It is evening now, the day settling into that quiet hour when thoughts drift like spacecraft across vast distances, when the mind begins to slow like light travelling from distant worlds. Perhaps you have looked up at night and seen a reddish point of light, brighter than most stars, and wondered about Mars, about the red planet that has captured human imagination for millennia, that calls to us across the void. Tonight, we are going to explore that story slowly, patiently, following humanity's relationship with Mars, from ancient observations to modern rovers, from mysterious red dot to explored world. This is not a tale of discoveries told breathlessly. It is something quieter, more patient. It is the story of gradual learning, of thousands of years of observation, of the patient work of understanding a neighbouring world, of the persistent human desire to know what lies beyond our own planet. If this story helps you rest tonight, feel free to like or subscribe. I am always curious where you are listening from. Comment your city and what time it is there. It creates a small connection knowing that people around the world are settling into sleep with these same stories, these same histories unfolding quietly in the darkness. Before we begin, take a moment to get comfortable. Dim the lights if you have not already. Adjust your pillow so your neck rests properly. Perhaps turn on some soft space sounds in the background, something that mimics the gentle hum of distant systems, the constant patient sound that becomes soothing through familiarity. Let the concerns of the day drift away like dust settling in Martian atmosphere. Tonight, you will journey through millennia of Mars observation, watching how Red Wanderer became explored world. Imagine you are standing on a rooftop in ancient Babylon, perhaps 3,000 years ago, the air being cool after desert day, the sky being perfectly dark, no city lights, no pollution, the stars being vivid, countless, the Milky Way being river of light across heavens. You are an astronomer, though that word does not exist yet. You are observer, record keeper, someone tasked with tracking celestial movements, with noting patterns, with maintaining the knowledge that helps predict seasons, helps organize agricultural cycles, helps maintain calendar. Among the fixed stars, the eternal patterns that never change, you notice wanderers, lights that move against the stellar background, that trace paths across the sky over weeks and months. 5 of these wanderers are visible to naked eye, 5 points of light that refuse to stay in one place among the constellations, that have their own journeys, their own rhythms. One of these wanderers glows reddish, distinctly coloured, not the white of Venus or Jupiter, but ruddy, the colour of blood, of fire, of war. You mark its position carefully, using the background stars as reference, noting which constellation it appears in, how far it has moved since last observation, the patient work of tracking being what astronomy is, being careful measurement, precise record keeping, the accumulation of data across nights, across months, across years. The clay tablet before you receives your marks, cuneiform script recording the position, the date, the observations. These tablets being what preserves knowledge, what allows patterns to be recognized, what makes astronomy possible. The reddish wanderer you track becomes known by different names across the ancient world, the Babylonians calling it Nergal after their god of war and pestilence, the colour being associated with blood, with conflict, with the destructive forces, the naming being natural given its appearance, given its unusual hue among the celestial wanderers. The observations continue across generations, astronomers replacing astronomers, the knowledge accumulating, the tablets multiplying, the understanding deepening slowly, patiently, over centuries of careful watching. The movement is puzzling, fascinating, the wanderer generally moving eastward against the stars, progressing through the zodiac, but periodically performing strange loops, moving backwards for weeks before resuming forward motion. The retrograde motion being mystery, being something requiring explanation, being phenomenon that challenges understanding of celestial mechanics that will not be properly explained for 2,000 years, until Copernicus and Kepler reveal the true nature of planetary orbits. You find yourself now in ancient Greece, perhaps in the 4th century before Common Era, the astronomical knowledge from Babylon having spread, being incorporated into Greek thinking, being refined, being theorized about. The Greeks call the reddish wanderer Ares, after their god of war, the association with conflict being maintained, being consistent across cultures, the colour being what everyone notices, being what demands explanation, being distinctive enough that all who observe agree on the martial character. The Greek astronomers are philosophers as well as observers, attempting to understand the mechanisms behind the movements, proposing geometric models, developing the concept of celestial spheres, imagining that wanderers are attached to rotating crystalline spheres, the model being ingenious attempt to explain retrograde motion to account for the complex paths, the epicycles being added to the model, smaller circles upon larger circles, the mathematics becoming elaborate, becoming what allows prediction of positions, what makes astronomy useful for calendar keeping, for navigation. The smell of papyrus and ink surrounds you as Greek astronomers document their observations, record their calculations, the scholarship being meticulous, being preserved in libraries, being copied and recopied, transmitted across centuries, the work of Ptolemy in 2nd century CE, codifying this knowledge, creating the Almagest, the comprehensive astronomical treatise that will dominate thinking for over 1,000 years, that will preserve Greek astronomical knowledge through medieval period. The Romans inherit Greek astronomy, adopting the names of gods, calling the reddish wanderer Mars after their own war deity. The name being what persists, being what we use today, the Roman influence being lasting, being transmitted through Latin into modern languages, into the scientific terminology, into the common understanding. The observations continue, Roman astronomers tracking Mars, noting its brightness variations, recognizing that sometimes it appears larger and brighter than other times. The opposition effect when Mars and Sun are on opposite sides of Earth, when Mars is closest, brightest, most favourable for observation. Centuries pass, the knowledge being preserved by Islamic scholars during European medieval period, the astronomical tradition being maintained in Baghdad, in Damascus, in Cairo, the Arabic astronomers making precise observations, improving instruments, developing better mathematical techniques, their work being what preserves and extends Greek astronomy, being what will eventually be transmitted back to Europe during Renaissance, enabling the scientific revolution. Time moves forward. You now find yourself in Italy in early 17th century, standing beside Galileo Galilei as he turns his newly improved telescope toward Mars. The year is 1610, the telescope being recent innovation, Dutch spectacle makers having discovered that lenses can be combined to magnify distant objects. Galileo having heard of this, having built improved versions, having turned them skyward with revolutionary results, having seen mountains on moons orbiting Jupiter, the cosmos being revealed as vastly different from what Aristotle taught, from what church doctrine maintained. Mars appears in the eyepiece, not as a point, but as a disk, small but definitely circular, definitely showing extent, the reddish colour being obvious, being confirmed, but the disk being tiny, the detail being minimal, atmospheric turbulence making the view shimmer and dance, the early telescope being crude, the magnification being low, Mars being too small, too distant for much detail to be discerned, but the observation being important, being confirmation that Mars has size, has substance, is world rather than just light. The telescopic observations improve over decades, better instruments being built, longer focal lengths, better lenses, the grinding and polishing being craft, being art, the opticians learning through trial and error how to create quality optics, how to minimize distortion, how to maximize clarity. Christian Huygens in 1659 makes breakthrough observation, sketching a dark triangular feature on Mars, a marking we now call Syrtis Major. The observation being first recorded surface feature on another planet, being proof that Mars has permanent markings, has geography, has places that can be identified, tracked, mapped. The Smelling Observatory is oil and brass, the telescope mechanisms being machined metal, requiring lubrication, the eyepieces being carefully cleaned, the observations being conducted in cold night air, observers bundling against chill, spending hours at eyepiece, eye becoming dark adapted, learning to see detail that casual glance would miss, the patient observation being skill, being what separates amateur from professional astronomer. Gian Domenico Cassini discovers the polar ice caps in 1666, observing white patches at Mars poles, noting that they grow and shrink with seasons, the recognition being profound, being first indication that Mars has seasonal cycles like Earth, that it experiences summer and winter, that ice advances and retreats, the parallel with Earth being obvious, being what makes Mars seem familiar, seem potentially habitable, seem like place where Earth-like processes might occur. The rotation period is determined through careful observation of surface features, noting when same marking returns to same position, the measurements converging on 24 hours and 37 minutes, remarkably close to Earth's day, the similarity being striking, being another indication that Mars is Earth-like. The observations building picture of Mars as smaller, colder version of Earth, as place that might harbour life, that might have vegetation, that might even have inhabitants. Though ancient astronomers worried about seeing Mars clearly through atmospheric distortion, concerns modern mission planners share about dust storms, though with better forecasting and significantly better cameras, the fundamental challenge remains the same. Seeing across vast distance, perceiving details across the gulf of space, the patient observation being what astronomy always requires, whether using naked eye or telescope or spacecraft. The 18th and early 19th centuries bring continued improvement in observations, better telescopes revealing more detail, astronomers creating maps of Mars showing dark and light regions, naming features after terrestrial locations or classical figures, the nomenclature being inconsistent, different astronomers using different schemes, the need for standardization being recognized but not yet achieved, the mapping being preliminary, being limited by technology, by the fundamental difficulty of observing small disk shimmering in turbulent atmosphere. William Herschel, in late 18th century, makes systematic observations, measuring the tilt of Mars' rotation axis, confirming that it is similar to Earth's 25 degrees versus Earth's 23 degrees, the similar axial tilt being what causes seasons, the recognition solidifying understanding that Mars is Earth-like in fundamental ways, the hope for life, for vegetation, for similarity with Earth being sustained, being reasonable given the observations available. You find yourself now in Milan in 1877, the year when Mars makes particularly close approach to Earth, an opposition when the planets align favourably, when Mars appears larger and brighter than usual, when astronomical conditions are optimal for observation. Giovanni Schiaparelli, Italian astronomer, has prepared for this, has access to good telescope, has spent previous oppositions practicing observation, learning Mars geography, preparing maps, this opposition being opportunity for detailed study, for discovering whatever can be seen. The observations begin night after night through the late summer and fall, of 1877, Schiaparelli at the eyepiece, sketching what he sees, the dark and light regions being familiar from previous observations, but new details emerging, linear features appearing to connect different regions, straight lines or nearly straight lines crossing the disk, the features being subtle, being at the limit of visibility, requiring excellent seeing conditions, requiring patient observation, requiring confidence in what the eye perceives. Schiaparelli calls these linear features canali, Italian word meaning channels, the term being neutral, meaning natural or artificial channels, being simply descriptive of what appears to be linear features, grooves, depressions, channels of some kind. The word being published in Italian astronomical journals, being reported in international astronomy publications, being translated into other languages, into English becoming canals, the translation being slightly wrong, canal in English implying artificial construction, implying engineering, implying intelligence. The canal controversy begins, other astronomers attempting to see what Schiaparelli describes, some confirming, seeing linear features, some unable to see anything, seeing only the usual dark and light patches, the debate intensifying, the question being whether canals are real or optical illusions, whether they are features of Mars or artifacts of observation, the human eye and brain being known to create patterns, to connect random features into lines, the pareidolia being well understood phenomenon, but the persistence of observations from multiple observers suggesting something real. Percival Lowell becomes obsessed with Mars and its canals, the wealthy American astronomer building Lowell Observatory in Flagstaff, Arizona, specifically to study Mars. The site being chosen for clear, dry air, for high altitude, for stable atmospheric conditions that allow steady viewing, the observatory being Lowell's passion project, being his life's work, being what he dedicates his fortune and energy to, the commitment being total, being what produces volumes of observations, maps, speculations. The Flagstaff Observatory air is thin and dry, the Arizona desert providing excellent seeing conditions, the nights being cold, the stars being brilliant, the telescope being fine instrument, being what allows detailed observation when atmosphere cooperates, when turbulence settles, when the rare moments of perfect clarity reveal Mars in exquisite detail, or seem to, the human factor being significant, the observer's expectations influencing perception, the desire to see canals making canals appear. Lowell creates elaborate maps showing hundreds of canals, intersecting networks, the straight lines covering the planet, connecting darker regions he interprets as seas or vegetation to polar caps. He interprets as water ice. The canal system being interpreted as planetary irrigation network, as desperate attempt by dying Martian civilization to bring water from poles to equatorial regions to sustain life on increasingly arid world. The interpretation being romantic, being dramatic, being what captures public imagination. The books Lowell publishes, Mars, 1895, Mars and its Canals, 1906, Mars as the Abode of Life, 1908, argue passionately for intelligent Martian life, for canal-building civilization, for Mars as inhabited world, the writing being eloquent, being persuasive to general public, being widely read, being what creates popular image of Mars in early 20th century, being what science fiction authors draw upon, being what shapes cultural understanding of Mars for generations. The scientific community is skeptical, most professional astronomers being unable to see the elaborate canal networks Lowell describes, photographic plates showing dark and light regions but no straight lines, the objective evidence not supporting the subjective observations, the debate being about observation reliability, about human perception, about the proper standards of evidence, the controversy simmering through the early decades of 20th century. Alternative explanations emerge, other astronomers suggesting that canals are optical illusions, that the eye connects random features, that straight lines appear where none exist, that seeing conditions create artifacts, that Lowell is seeing what he wants to see, the criticism being gentle initially, becoming harsher as Lowell persists, as he refuses to acknowledge doubts, as he continues publishing books and maps showing ever more canals, the scientific disagreement becoming personal, becoming bitter. The resolution comes gradually as photographic techniques improve, as larger telescopes come online, as more systematic observations are conducted, the consensus developing that canals do not exist, are not features of Mars, are artifacts of observation, the embarrassment being significant, the canal episode becoming cautionary tale about observation bias, about the need for objective evidence, about the dangers of letting theory influence observation, the lesson being learned, being applied to future astronomical work. But Lowell's popularization has lasting impact, the Mars of popular culture being canal-covered Mars, being inhabited Mars, being dying civilization Mars, the science fiction of early and mid-20th century drawing heavily on Lowell's vision, H.G. Wells' War of the Worlds, 1898, Edgar Rice Burroughs' Barsoom series, beginning 1912, countless other works imagining Mars as inhabited, as having civilization, as being place where adventures occur, the fictional Mars being more influential than real Mars for much of 20th century. Time advances, technology improves, spectroscopy develops, the technique of splitting light into spectrum, analysing which wavelengths are absorbed or emitted, revealing chemical composition of distant objects. Mars light is analysed spectroscopically, revealing atmospheric composition, the discovery being sobering, being revision of understanding, being recognition that Mars is not Earth-like, not hospitable, not place where humans could survive without protection. The spectrum shows that Mars' atmosphere is thin, much thinner than Earth's, containing mostly carbon dioxide, very little oxygen, very little water vapour, the composition being hostile to Earth life, being indication that Mars' surface is inhospitable, is cold, is dry, the growing understanding being that Mars is harsh world, is place where life as we know it would struggle, where water cannot exist as liquid due to low pressure, where temperatures are consistently below freezing, except perhaps briefly at equator during summer days. Infrared observations measure surface temperatures, revealing average temperature around -60 Celsius, -80 Fahrenheit. The cold being extreme, being what makes liquid water impossible, the daily temperature swings being large, thin atmosphere providing little insulation, day-night variations being hundreds of degrees in some locations, the temperature regime being what rules out comfortable life, what suggests that any life must be hardy, must be microbial, must survive extreme conditions. The polar caps are analysed spectroscopically, revealing composition, showing that caps are a mixture of water ice and frozen carbon dioxide, dry ice. The seasonal changes being explained by carbon dioxide freezing out in winter, sublimating in summer, the water ice being permanent, or mostly permanent, the dry ice being seasonal, the understanding being refined, being based on solid evidence rather than speculation, being what science produces when careful measurement replaces hopeful imagination. You find yourself now in the 1960s, the space age having arrived, Sputnik having demonstrated that spaceflight is possible, that reaching orbit is achievable, that sending machines into space is within human capability. The attention turning to Moon first, but also to planets, to Mars being obvious target, being closest planet beyond Earth, being place where robot spacecraft might reach, might photograph, might reveal secrets that telescopes cannot discern. The Soviet Union attempts first, their Mars program beginning in 1960. the missions being ambitious, being attempts to fly past Mars, to photograph it, to return data, the launches occurring but immediately encountering problems, rockets failing, spacecraft failing to leave Earth orbit, the difficulties being what characterize early space exploration, the reliability being poor, the technology being immature, the failures outnumbering successes, the patient persistence being what eventually produces results. Mars 1 launches in November 1962, successfully leaving Earth, beginning the long coast toward Mars, the spacecraft functioning initially, transmitting data, following trajectory, but contact being lost several months into mission, the radio failing, the spacecraft continuing on ballistic path but being blind, deaf, unable to complete mission, passing Mars without returning any data, the failure being frustrating but being typical, being what early space missions experience, the difficulty being learning how to make spacecraft reliable across months of flight, across millions of miles, across the radiation and vacuum of space, the clean room smells of antiseptic, engineers wearing white coats and hair coverings to prevent contamination, spacecraft being assembled in controlled environment, every component being tested, being qualified, being verified, the quality control being extensive, but failures occurring anyway, space being unforgiving, the smallest defect causing mission failure, the learning curve being steep, being paid for in failed missions, in lessons learned, in the gradual improvement of reliability. NASA enters Mars exploration with Mariner program, Mariner 3 and 4 being Mars-bound spacecraft launched in November 1964. Mariner 3 failing when shroud does not separate, dooming the spacecraft, but Mariner 4 functioning correctly, separating cleanly, beginning 7-month voyage to Mars, the spacecraft being simple by modern standards, being solar-powered, having scientific instruments, having camera to photograph Mars, the mission being to fly past, to return first close-up images, to reveal Mars as it truly is. The mission control at JPL is tense during critical phases, engineers monitoring telemetry, tracking spacecraft position, sending commands, receiving acknowledgements delayed by speed of light, the communication time being already significant, being 20 minutes round trip when Mars and Earth are reasonably close, making real-time control impossible, making autonomous operation essential, the spacecraft must handle problems itself, must execute pre-programmed sequences, must survive without human intervention. Mariner 4 approaches. Mars in July 1965, the closest approach being planned trajectory, the camera being activated, taking 22 photographs during flyby, the data being stored on tape recorder, being played back slowly over following days, each image taking hours to transmit, the data rate being limited by power and distance, the black and white images arriving line by line, engineers colouring printouts by hand using pastels based on signal strength, unable to wait for proper processing, eager to see what Mars looks like up close. The images are shocking, revolutionary, disappointing, revealing Mars as cratered desert, as moon-like world, as ancient dead surface showing billions of years of cratering, no canals, no vegetation, no obvious signs of activity, just craters and more craters. The vision of Mars being transformed instantly, irreversibly, the Llewellian Mars dying in those 22 photographs, the real Mars being born, being place that is geologically dead, that has not changed significantly in eons, that offers no evidence of life, of water, of the hoped-for similarity with Earth. The scientific community processes the results, the data being analysed, crater counts being performed, surface age being estimated as billions of years, the recognition being that Mars has no plate tectonics, no crustal recycling, no erosion to erase craters, the surface being preserved record of solar system history, being ancient in ways that Earth is not, Earth's active geology destroying old surfaces, recycling crust, Mars keeping permanent record, being geologically stable, being frozen in time. The public reaction is mixed. Disappointment about lack of life being balanced by excitement about actual knowledge, about real photographs from another planet, about the achievement of interplanetary spaceflight, the Mariner for success being triumph of engineering, of planning, of the careful work that makes space missions possible, the images being treasured even as they destroy cherished beliefs, truth being valued over comfortable fiction, knowing being better than speculating. The story continues forward through these decades, through the accumulation of knowledge, through the patient observations spanning millennia, from Babylonian astronomers tracking Red Wanderer, through Schiaparelli and Lowell imagining canals, to Mariner revealing cratered reality, the progression being from mystery to understanding, from speculation to knowledge, from Mars, the idea, to Mars, the place, the transformation being what science achieves, being product of careful observation, rigorous analysis, technological capability enabling direct exploration. The journey being incomplete, being ongoing, being what continues into present and future, the red planet revealing itself slowly, patiently, across the centuries of human attention, human wondering, human effort to understand neighbouring world. The Red Wanderer moves differently from the others, its path being complex, sometimes moving forward through the constellations, sometimes slowing, sometimes stopping, sometimes moving backward, this retrograde motion being mystery, being what requires explanation, being what challenges understanding of celestial mechanics. You do not know why it does this. You only observe, only record, only preserve the data that future generations will use, that will eventually explain what you witness but cannot comprehend. The colour is significant, this reddish hue being distinct, being what causes you and your colleagues to associate this wanderer with war god Nergal, the deity of conflict, of strife, the red being colour of blood, of violence, the connection being natural, being what humans do, connecting celestial phenomena to earthly concepts, to gods and myths, to the stories that make sense of cosmos, that provide meaning to observations. The night passes slowly, the observations continuing, the cool air being comfortable, the silence being broken only by occasional sounds of city below, of dogs barking, of night watchmen calling. But here on rooftop the focus is upward, is on the heavens, on the patient work of tracking, of measuring, of maintaining the knowledge that previous astronomers built, that you add to, that you will pass forward to those who come after. The continuity being what makes astronomy possible, being accumulation across generations. Centuries pass, the knowledge spreading, different cultures observing the same wanderer, giving it different names. The Egyptians track it, incorporating observations into their astronomical records, their calendar systems, their religious observances. The Greeks name it Ares, after their war god, the red colour again suggesting violence, combat, the association being universal across cultures that observe it, the colour being what determines interpretation, what shapes mythology. You find yourself now in ancient Rome, the wanderer being named Mars, after Roman god of war, the name that will persist, that will become standard, that we still use millennia later. The Roman astronomers continue the work of observation, of tracking, the knowledge being preserved in texts, in scrolls, in the careful documentation that allows astronomy to progress, to become more sophisticated, to move toward understanding rather than just observation. The mystery of retrograde motion persists across these centuries, various explanations being proposed, Ptolemy's geocentric model requiring complex epicycles to explain why Mars sometimes moves backward, the mathematics being sophisticated, being able to predict positions, but the underlying mechanism being wrong, being based on false assumption that Earth is centre, that everything revolves around us, the model working despite being fundamentally incorrect, the predictions being adequate for navigation, for calendar keeping, for the practical purposes that astronomy serves. The medieval period sees Islamic astronomers preserving and expanding classical knowledge, building observatories, improving instruments, making more accurate measurements. The work being careful, being patient, being what maintains astronomical tradition through centuries when European astronomy stagnates, when knowledge is preserved in monasteries but not advanced, the Islamic scholars being who keep astronomy alive, who improve it, who pass enhanced knowledge back to Europe during Renaissance. Time moves forward, bringing transformation, bringing new understanding. You stand now beside Nicholas Copernicus in early 1500s, the Polish astronomer proposing revolutionary idea that Sun is centre, that Earth and other planets orbit it, the heliocentric model being what explains retrograde motion naturally, being what shows that Mars appears to move backward when Earth, being closer to Sun and moving faster, overtakes it. The relative motion creating illusion of reversal, the elegant explanation being what Copernicus offers, being what begins to reveal true nature of solar system. The resistance is substantial, the geocentric model being entrenched, being supported by church, by tradition, by common sense observation, that Earth seems stationary, that sun and stars appear to move, the evidence of motion being what everyone experiences daily. Copernicus publishes cautiously, the book appearing as he dies, the idea spreading slowly, being debated, being refined by later astronomers, particularly Johannes Kepler, who discovers that orbits are elliptical, not circular, being what makes predictions more accurate, being what shows Copernicus is essentially correct, even if details need adjustment. You find yourself now in 1609, standing beside Galileo Galilei in Italy, the scholar having heard of Dutch invention, the telescope, and building his own version, improving the design, achieving magnification sufficient for astronomical observation, the transformation being what this instrument brings, being ability to see details previously invisible, to observe rather than just measure positions, to witness the universe rather than merely track it. Galileo points his telescope at Mars, the reddish point of light becoming disk, becoming object, with visible extent rather than just point. The revelation being significant, being confirmation that planets are worlds, are places with physical existence, not just lights in sky, not just geometric points to be calculated, but actual objects with surfaces, with substance. The philosophical impact being profound, being what makes universe real in new way, being what transforms astronomy from pure mathematics into observational science about physical objects. The detail visible through early telescopes is minimal, Mars being small, being distant, the atmospheric distortion being severe, the patient waiting for moments of good seeing, being what observation requires, the nights when atmosphere steadies enough for clear view being rare, being precious, being when useful observations can be made, the frustration being constant companion of telescopic astronomy, being what observers must endure, must overcome through patience, through persistence. Christian Huygens observes Mars systematically in 1659, making careful drawings, sketching features including dark triangular marking that we now call Certis Major, the feature being prominent, being what identifies Mars, being landmark that allows tracking rotation. Huygens' observations show that same features return after approximately 24 hours and 37 minutes. Being very close to Earth Day, being what reveals that Mars rotates, that it has day-night cycles similar to ours. The similarity being encouraging, being what suggests Mars might be Earth-like, might be habitable, might even support life. Giandomenico Cassini observes polar ice caps in 1666, the bright white regions at Mars' poles being visible even through crude telescopes. The observation being significant, being what shows Mars has poles like Earth, has ice like Earth, has seasons like Earth because caps grow in winter, shrink in summer, the evidence accumulating that Mars resembles our world, that it is not just random celestial object, but place with familiar features, with phenomena we recognize, with characteristics that suggest it might be not so different from Earth. The understanding grows through 1700s and 1800s, better telescopes revealing more detail, observers mapping surface features, tracking seasonal changes, the dark markings that some interpret as vegetation, as areas that grow darker in spring as hypothetical plants respond to warmth and moisture. The speculation being what humans do, seeing patterns, imagining life, wanting Mars to be inhabited, to be a place where we are not alone, where life has arisen independently, where universe creates biology, not just on Earth. The rotation period is refined to 24 hours, 37 minutes 22 seconds, remarkably close to Earth's day, being what makes Mars attractive for future colonization discussions, being what suggests human adaptation would be easier than on world with very different day length, the practicality being considered even before space travel is possible, the imagination racing ahead of capability, the dreams outpacing technology. Though 19th century astronomers worried about seeing Mars clearly through atmospheric distortion, concerns modern mission planners share about dust storms, though with better forecasting and significantly better cameras, the fundamental challenge remains: understanding distant world through patient observation, overcoming obstacles, accumulating knowledge gradually, being what Mars exploration has always required, being what it still requires today. You stand now in 1877, a significant year, Mars being at opposition, being closest approach to Earth in its orbit, being when it appears largest and brightest, being optimal time for observation. Giovanni Schiaparelli, Italian astronomer, observes systematically, making detailed maps, sketching linear features that he terms canali, meaning channels in Italian, the term being neutral, being descriptive, meaning natural or artificial watercourses, being what geographers use for rivers and straits, being innocent term that will cause enormous confusion. The translation to English renders canali as canals, implying artificial construction, implying engineering, implying intelligent builders, the mistranslation being what transforms Mars in popular imagination, being what creates controversy, being what leads to decades of speculation about Martian civilization, about inhabitants, about the possibility that Mars is not just inhabited but civilized, but technologically advanced, but possessing engineering capability to construct planet-wide irrigation systems. Percival Lowell enters the story now, wealthy American interested in astronomy, becoming obsessed with Mars and particularly with canals, building Flagstaff Observatory in Arizona specifically for Mars observation, the location being chosen for altitude, for clear dry air, for excellent atmospheric seeing, the dedication being complete, being what drives Lowell to spend fortune and career on Mars study. Lowell observes obsessively, mapping hundreds of canals in intricate networks, publishing books and maps, lecturing publicly, arguing that canals are artificial, our irrigation system built by dying Martian civilization trying to bring water from polar ice caps to equatorial deserts. The narrative being compelling, being what captures public imagination, being what makes Mars exciting, being what sells books and fills lecture halls, being what makes Lowell famous. The scientific community is divided, some supporting Lowell, seeing canals in their own observations, others being sceptical, being unable to see linear features, suspecting optical illusions, questioning whether lines are real or artifacts of observing at limits of telescopic resolution, of human eye connecting random features into patterns, of psychological phenomenon called pareidolia, where brains see patterns that are not there. The debate being intense, being what characterizes astronomy of this period. The observations continue for decades, better photographs being taken but being ambiguous, some showing linear features, others not. The debate continuing into 1920s and 1930s, eventually consensus forming that canals do not exist, that they are observational artifacts, that Lowell's maps show more imagination than reality, but impact being lasting popular image of Mars being shaped by Lowell, being what science fiction builds on, being what public believes despite scientific rejection. The spectroscopic analysis begins early 1900s, new technique allowing analysis of Mars light, splitting it into spectrum, examining which wavelengths are absorbed or emitted, revealing information about atmospheric composition, about temperature, about conditions on Mars, the observations being patient, being accumulation of many nights of data, being what transforms understanding from surface features to physical conditions. The results are disappointing for those hoping for Earth like Mars, the spectrum showing very little oxygen, very little water vapour, mostly carbon dioxide, thin atmosphere, the conclusions being that Mars is cold, is dry, is not particularly Earth-like despite superficial similarities, the hope for vegetation being reduced, the possibility of complex life being questioned, the Mars of imagination beginning to diverge from Mars of measurement. The temperature measurements using infrared observations reveal surface temperatures averaging -60 degrees Celsius, with enormous day-night swings. The thin atmosphere providing little insulation, heat being radiated away rapidly at night, the conditions being hostile, being what makes surface life unlikely, being what suggests any life would be microbial, would be underground, would be in protected environments, not thriving vegetation carpeting plains, as some imagined. The story continues through these decades, through patient accumulation of knowledge, through transformation from mystery to mapped world, from imagination to measurement, the progression being slow, being careful, being what science requires, being how understanding develops through observation, through instrument improvement, through patient work across generations, the red dot in ancient skies becoming explored world, becoming place we will soon visit with spacecraft, with cameras, with instruments designed to reveal Mars as it truly is. The journey advancing from speculation toward direct exploration, toward the space age that approaches, toward missions that will transform understanding completely, that will make Mars real place rather than distant mystery. The narrative proceeding forward through time toward the moment when humans send machines across void to touch another world. The space age transforms Mars exploration completely, bringing capability to send machines across void, to observe directly rather than through telescope, to photograph from close range, to eventually land on surface, to touch another world with human-built instruments. The early attempts are Soviet, the space race extending beyond Earth orbit, beyond Moon, toward planets, Mars being obvious target, being nearest planet beyond Earth, being destination that represents frontier, that tests technology, that promises glory for nation that reaches it first. You find yourself now at Soviet space facility in early 1960s, watching preparation of Mars 1M spacecraft, the vehicle being designed for Mars flyby, for first attempt to reach another planet, the ambition being enormous, the challenge being unprecedented, no spacecraft having travelled so far, having functioned so long, having accomplished interplanetary journey. The clean room smells of electronics and solvents, technicians wearing white coats, working carefully, testing systems, checking connections. The spacecraft being complex assemblage of instruments, cameras, radio transmitters, solar panels, attitude control systems. Everything must function perfectly across months of flight, across millions of miles, across the radiation and vacuum of space. The launch comes in October 1960, the rocket lifting off, climbing through atmosphere, but failing to reach orbit, payload crashing back to Earth, mission ending before it truly begins, the failure being first of many, being what characterizes early Mars exploration, the difficulty being apparent, being what shows that reaching Mars is harder than reaching Moon, requires more energy, more precision, more reliability. The technology not being ready, not being mature enough, the learning curve being steep. More attempts follow. Sputnik 22, launching in 1962, reaching orbit but then exploding, never leaving Earth vicinity, the pattern continuing, failure after failure, the Soviets persisting, trying different approaches, improving designs, fixing problems, the dedication being what space exploration requires, the acceptance that failures are learning opportunities, that each attempt teaches lessons, advances understanding, brings success closer, even when mission fails. Mars 1 launches successfully in November 1962, leaving Earth orbit, beginning journey toward Mars, the spacecraft functioning initially, transmitting data, responding to commands, the mission appearing successful, but contact being lost in March 1963, still months from Mars arrival, radio failing, spacecraft continuing on ballistic trajectory, but being blind, deaf, unable to complete mission, passing Mars without returning data, the frustration being profound, being what drives improvements, being what motivates better quality control, better testing, better reliability engineering. The American effort proceeds in parallel, NASA developing Mariner program, series of planetary flyby spacecraft, Mariner 3 and 4 being Mars missions, launching in November 1964, the missions being carefully planned, spacecraft being tested exhaustively, every component being qualified, every system being verified, the preparation being meticulous, being what NASA culture emphasizes, being focused on reliability, on success, on doing things correctly rather than quickly. Mariner 3 launches first, rocket performing correctly, but shroud protecting spacecraft during ascent failing to separate, dooming mission, spacecraft being trapped, unable to deploy solar panels, unable to function, the failure being mechanical, being simple but fatal, being what shows that even simple things must work perfectly, that space is unforgiving, that smallest problem can destroy mission. Mariner 4 launches weeks later, shrouds separating correctly, spacecraft deploying solar panels, systems activating, trajectory being correct, the mission proceeding as planned. Beginning 7-month coast toward Mars, the spacecraft being autonomous, being pre-programmed to execute scientific observations, unable to receive real-time commands due to distance, due to signal delay that grows as spacecraft recedes from Earth. You stand now at Jet Propulsion Laboratory in Pasadena, California, July 1965, Mission Control Monitoring. Mariner 4 approached to Mars, the room being filled with engineers, with scientists, with management, everyone being tense, being excited, being aware that success or failure depends on engineering done months ago, on testing conducted on Earth, on programming uploaded before launch, the spacecraft being beyond human control, being on its own, being testament to careful preparation or victim of inadequate testing, the outcome being determined, being knowable only through patient waiting. The smell is coffee and cigarette smoke, the style being 1960s, smoking being allowed indoors, being ubiquitous, the engineers drinking coffee constantly, staying alert through long shifts, monitoring telemetry, checking systems, the computer banks filling walls, using vacuum tubes and transistors, being primitive by modern standards but sophisticated for era, the whole facility being monument to human capability, to engineering excellence, to systematic approach to complex problems. The signal delay is now 20 minutes round trip, meaning that observations received on Earth show what spacecraft did 20 minutes ago, that commands sent now will not be executed for 10 minutes, making real-time control impossible, making autonomous operation essential. The spacecraft must make decisions, must handle problems, must complete mission without human intervention. The autonomy being what mission requires, being what makes interplanetary exploration possible. The closest approach occurs on July 14th, 1965, spacecraft passing Mars at distance of about 6,000 miles, much closer than Earth-based telescopes, close enough for cameras to see details impossible from Earth, the pre-programmed sequence activating, camera taking 22 photographs during flyby, images being stored on tape recorder, being played back slowly over following days and weeks, the transmission rate being limited, being only 8 bits per second, each image taking hours to transmit. The engineers cannot wait, colouring printouts by hand using pastels, assigning colours based on signal strength, creating crude images that show what Mars looks like before proper photographic processing, the anticipation being unbearable, the curiosity being overwhelming, the desire to see Mars, to know what lies below those clouds of dust, to discover whether canals exist, whether vegetation grows, whether Mars is Earth-like world or something different, the questions being about to be answered, the speculation being about to end. The first images arrive showing craters, ancient cratered surface, resembling Moon more than Earth, the shock being immediate, being profound, the vision of Mars being transformed, the Llewellian Mars dying in these photographs, the Mars of canals and vegetation and dying civilization being replaced by Mars of craters, an ancient geology and apparent lifelessness, the disappointment being real, being emotional, being what everyone feels despite scientific detachment, despite professional objectivity, the hope dying, the reality being harsh. More images continue arriving, all showing similar features, heavily cratered terrain, ancient surface, no canals visible, no evidence of vegetation, no signs of current geological activity, just craters and more craters. The landscape being what billions of years of meteorite bombardment creates, what lack of erosion preserves, what geologically dead world looks like. The surface age being estimated at billions of years based on crater density. The recognition being that Mars has not changed significantly since early solar system. The detailed analysis begins, scientists studying photographs, counting craters, measuring their sizes, comparing to lunar surface. The conclusion being that Mars lacks plate tectonics, at least in regions photographed, that surface is ancient, that erosion is minimal, that water is not currently reshaping landscape, that Mars is inactive world, is cold desert, is nothing like imagined Mars of popular culture, of science fiction, of hopeful speculation. The public reaction is mixed, disappointment about lack of canals being balanced by excitement about achievement, about first close-up photographs from another planet, about successful interplanetary mission, the Mariner 4 images being published worldwide, being seen by millions, being what makes Mars real place rather than abstraction, being what shows that space exploration can reveal truth about other worlds, can answer questions, can transform understanding. The scientific community processes results carefully, publishing papers, analysing data, revising understanding of Mars, the textbooks being rewritten, the popular books being updated, the vision of Mars being fundamentally altered, permanently, irreversibly, the Mariner 4 mission being watershed, being dividing line between old Mars and new Mars, between speculation and knowledge, between imagination and observation. More Mariner missions follow, Mariner 6 and 7 in 1969 conducting additional flybys, photographing different regions, confirming Mariner 4 results, showing that cratered terrain is widespread, that Mars is indeed ancient world. The additional data refining understanding, providing more detailed mapping, revealing that Mars has variety of terrains, some heavily cratered, some less so, suggesting complex geological history even if current activity is minimal. Mariner 9 arrives in 1971, being first spacecraft to orbit Mars, to remain in proximity, to map entire planets systematically, the mission being transformative, being what reveals Mars in comprehensive detail, being what discovers features that flybys missed, that change understanding again, that show Mars is more complex than Mariner 4 suggested, is more interesting, is more geologically diverse. You watch from mission control as Mariner 9 enters orbit, the spacecraft firing rocket to slow down, to be captured by Mars gravity. The manoeuvre being critical, being make or break moment, the tension being high, the relief being palpable when telemetry confirms successful orbital insertion, when spacecraft begins its primary mission, when cameras begin systematic mapping of planet below. The timing is unfortunate, massive dust storm being underway, obscuring surface, the global storm being what happens occasionally on Mars, winds lifting dust into atmosphere, the particles staying suspended for weeks or months, the whole planet becoming featureless orange globe, the storm being what Mariner 9 encounters, what delays useful photography, what frustrates mission planners who must wait for dust to settle, who must be patient while storm slowly dissipates. The waiting is difficult, spacecraft being in orbit, functioning correctly, but unable to photograph surface through dust, the mission being delayed by Martian weather, by phenomenon beyond human control, the patience being what space exploration often requires, the acceptance that conditions must be right, that sometimes waiting is only option, that Mars will reveal itself when ready, not when we demand. As dust settles, features begin emerging, first being dark spots that resolve into volcanic peaks rising above dust layer, the volcanoes being enormous, being larger than any on Earth, Olympus Mons being shield volcano nearly 3 times height of Mount Everest, being largest volcano in solar system, the discovery being stunning, being revelation that Mars has experienced volcanism, that it has geological features of extraordinary scale, that it is not just cratered desert, but complex world with varied geology. More features appear as dust clears, vast canyon system being revealed, Valles Marineris being rift valley stretching thousands of miles, being deep enough to dwarf Grand Canyon, being evidence of tectonic activity, of crustal stress, of geological processes that shaped Mars, the canyon being what shows Mars has been geologically active, has experienced forces that fractured crust, that created features of continental scale. The most significant discoveries are dry riverbeds, ancient channels carved by flowing water, the features being unmistakable, being what water creates, being evidence that Mars once had liquid water on surface, that climate was different billions of years ago, that Mars was warmer, wetter, more Earth-like in distant past. The implication being that Mars might have been habitable, might have supported life, might have biological history, even if surface is sterile now. The excitement is renewed, the disappointment from Mariner 4 being replaced by new hope, by recognition that Mars has interesting history, that past conditions were favourable for life, that searching for evidence of ancient life is worthwhile, that Mars still holds mysteries, still offers discoveries, still justifies exploration, the vision of Mars being revised again, being updated, being enriched by Mariner 9 observations. The Viking program represents next major step. NASA planning ambitious dual missions, Viking 1 and Viking 2, each consisting of orbiter and lander. The orbiters mapping from above, the landers touching down, analysing soil, searching for life, photographing surface, measuring weather, the missions being most complex, robotic exploration ever attempted, being what requires years of preparation, extensive testing, careful planning. You find yourself now watching Viking preparation in mid-1970s, the spacecraft being assembled in clean rooms, engineers working meticulously, testing every component, every system. The landers being particularly complex, having heat shields for atmospheric entry, parachutes for descent, retro-rockets for final landing, robotic arm for collecting soil samples, biology experiments for life detection, cameras for surface photography, weather instruments for meteorological monitoring, the whole package being sophisticated laboratory, being what will operate autonomously on Mars' surface. The biology experiments are carefully designed, 3 different approaches to detecting life, each based on different metabolic assumptions, the experiments being what scientists debated for years, being consensus approach to life detection, being tests that should reveal microbial activity if present, that should distinguish between biological and chemical processes, that should answer question of whether Mars harbours life. Viking 1 launches in August 1975, beginning 11-month journey to Mars, the spacecraft being precise combination of orbiter and lander, travelling together until Mars arrival when lander separates, descends, attempts landing. The mission profile being complex, being what requires everything to work correctly, being high risk, high reward endeavour. The arrival at Mars is July 1976, exactly 7 years after Apollo 11 moon landing, the timing being symbolic, being reminder of American space achievement. The Viking 1 orbiter enters Mars orbit successfully, begins photographing surface, searching for suitable landing site, the original site being deemed too rough, too risky, alternative sites being evaluated, the landing being delayed while safer location is identified, the caution being appropriate, being what mission success requires. The landing site is selected in Planitia, relatively smooth plain, good lighting conditions, interesting scientifically, accessible for landing, the decision being made, landing sequence being programmed, the date being set for July 20th, 1976, the anniversary of moon landing being intentional, being what NASA chooses, being symbolic connection between lunar and Martian exploration. You stand in JPL mission control on July 20th, watching monitors, listening to communications, the room being tense, being crowded with engineers and scientists and managers, everyone knowing that next hour will determine mission success, that entry, descent and landing is most dangerous phase, that many things can go wrong, that spacecraft is on its own, autonomous, pre-programmed, beyond human help. The lander separates from orbiter, begins descent toward Mars, entering thin atmosphere at thousands of miles per hour, heat shield protecting against friction heating, the spacecraft being buffeted, being shaken, experiencing forces, temperatures, stresses that testing simulated but actual landing validates. The telemetry streaming to Earth showing everything is nominal, is proceeding correctly. But data being 20 minutes old, the actual events being what happened 20 minutes ago, outcome being already determined, being knowable only through patient waiting for signals. The parachute deploys, slowing descent, the heat shield jettisons, exposing lander, radar altimeter, activating, measuring height above surface, retro-rockets igniting, slowing final descent, the sequence being precisely timed, being choreographed through years of engineering, being what allows soft landing, being what brings spacecraft gently to surface, rather than crashing, the automation being what makes it possible, being triumph of engineering, of systematic design, of exhaustive testing. The signal arrives, simple message, touchdown, the confirmation that Viking 1 has landed successfully, is on Mars' surface, is functional, The relief is enormous, the celebration immediate, the achievement being historic, being first successful Mars landing, being what opens era of surface exploration, of direct investigation, of touching Martian soil, of standing on another world through robotic proxy. The first image transmits slowly, line by line, black and white photograph showing footpad resting on rocky surface, orange sky above, the alien landscape being revealed, being what no human has seen before, being view from Mars' surface, being perspective that transforms understanding, that makes Mars real place, tangible location, somewhere rather than distant abstraction. The colour images follow, showing salmon pink sky, rusty red rocks, orange-brown soil, the colours being what iron oxide creates, being rust essentially, being what gives Mars its reddish appearance, the landscape being desert, being boulder-strewn plain, extending to horizon, being desolate, being beautiful in stark way, being what Mars is, cold desert, under pink sky. The robotic arm extends, scoops soil sample, delivers to biology experiments, the analysis beginning, the life detection tests running, searching for metabolic activity, for organic compounds, for evidence of biology, the results being ambiguous. Some tests giving positive results, others negative, the interpretation being difficult, being debated, the consensus eventually forming that results are explainable by chemistry rather than biology, by unusual soil chemistry rather than life, but questions remaining, controversy continuing decades later. The weather station operates daily, measuring temperature, wind speed, atmospheric pressure, the data revealing Mars climate, the temperatures ranging from -80 Celsius at night to -30 during day. The thin atmosphere providing little insulation, the winds being light despite dust storms, the pressure being less than 1% of Earth's, the conditions being hostile, being what makes surface life difficult, being environment that challenges survival. Viking 2 lands in September 1976 in Utopia, Planitia. Different region, similar results, more photographs, more soil analysis, more weather data, the 2 landers providing dual perspective, confirming findings, extending coverage, the missions being successful beyond expectations, operating for years rather than months. Viking 1 functioning until 1982, Viking 2 until 1980. The longevity being testament to robust design, to quality engineering, to careful construction. Remember those ancient astronomers tracking red wanderer across sky, marking positions on clay tablets? Now cameras photograph surface, robotic arms touch soil, instruments analyze atmosphere, the progression being complete, being transformation from distant observation to direct exploration, the patience being same, the careful measurement being same, the dedication to understanding being same, only methods changing, only technology improving, the fundamental human curiosity being constant. The decades after Viking bring gap in surface exploration, orbiters continuing to map Mars, improving resolution, discovering more features, more evidence of ancient water, more complexity, but no landers touching down, the expense being prohibitive, the risk being high, the technology being developed, being refined, the next generation being prepared. Mars Pathfinder breaks the gap in 1997, innovative mission using airbags for landing, bouncing to stop rather than using only retro rockets. The approach being cheaper, being what allows mission to fly, the spacecraft carrying small rover, Sojourner, being microwave oven-sized, 6-wheeled, solar-powered, being technology demonstration, being proof that rovers can work on Mars. You watch Pathfinder landing in July 1997, the airbags inflating, spacecraft bouncing across surface, rolling to stop, deflating, petals opening, revealing rover. The unconventional approach working perfectly, the landing being successful, being beginning of new era, being what makes rovers standard for Mars exploration. Sojourner emerges, drives down ramp, begins exploring around lander, the rover being small but capable, carrying X-ray spectrometer, analysing rock composition, finding that some rocks are andesites, are volcanic rocks similar to Earth's, suggesting complex geology, suggesting that early Mars might have had plate tectonics, water cycling, processes that Earth has, the implications being significant, being what makes Mars more interesting, more Earth-like in past, if not present. The public engagement is unprecedented. Pathfinder website receiving billions of hits, crashing servers, people worldwide following mission, watching rover drive, seeing new images, the fascination being what Mars inspires, being connection people feel to exploration, to discovery, to humanity reaching beyond Earth. The mission succeeding not just scientifically but culturally, inspiring generation, demonstrating that Mars exploration captures imagination, maintains interest, justifies investment. The twin Mars exploration rovers, Spirit and Opportunity, launch in 2003, landing in January 2004, the missions being designed for 90 days, being expected to drive a few hundred meters, to analyse limited number of rocks, to provide baseline data. The conservative estimates being based on Mars's harsh environment, on dust accumulation on solar panels, on wear on components, but rovers exceeding expectations dramatically, spectacularly. Spirit lands in Gusev crater, operates until 2010, driving nearly 8 kilometres, the longevity being what nobody expected, being triumph of engineering, of robust design, of capability to handle Martian conditions, the rover finding evidence of ancient hot springs, of volcanic activity, of complex water history, the science return being enormous, being far beyond mission requirements. Opportunity lands in Meridiani Planum, operates until 2018, driving over 45 kilometres, functioning for 14 years, being what makes it legendary, being rover that wouldn't quit, that kept operating year after year, discovering that landing site was once covered by acidic sea, finding hematite spherules nicknamed blueberries, evidence of water percolating through rock, the discoveries being continuous, being what rover missions provide, sustained exploration, patient investigation, thorough analysis. The experience of operating rovers is patient work, mission controllers planning drives carefully, analysing terrain, selecting targets, uploading commands overnight, rover executing next day, results arriving following day, the cycle being slow, being deliberate, being what signal delay requires, being what makes Mars exploration methodical, careful, the opposite of instant gratification, being long-term commitment, being dedication to systematic investigation. The dust devils are photographed, whirlwinds crossing plains, lifting dust, the motion being what sometimes cleans solar panels, extending rover life, being lucky breaks that mission planners appreciate, that cannot be predicted, that Mars occasionally provides, the planet being dynamic in small ways, having weather, having seasons, having processes that continue, that affect operations. Phoenix Lander arrives in 2008, landing in North Polar region, digging into soil, analysing ice, confirming water ice just below surface, the discovery being expected but being important, being confirmation that Mars has substantial water reserves frozen in soil, that resources exist for future missions for eventual human exploration, the practical implications being significant. Curiosity rover represents leap in capability, car-sized rover, nuclear-powered, not dependent on solar panels, able to operate through winter, through dust storms, the power being continuous, being reliable, the rover launching in 2011, landing in 2012 using Skycrane innovative descent system that hovers on rockets while lowering rover on cables. The approach being complex but working perfectly, being what allows precise landing, being what delivers 1-ton rover gently to surface. The landing site is Gale Crater, location chosen for thick sequence of layered sediments, for Mount Sharp rising from crater centre. The geology being what attracts scientists, being record of Mars history, being layers deposited over billions of years, being archive of environmental changes, of climate shifts, of Mars evolution. You watch Curiosity operations from mission control, the rover being sophisticated laboratory, carrying instruments for analysing rock chemistry, mineralogy, for detecting organic compounds, for measuring radiation, for assessing habitability, the capability being comprehensive, being what allows detailed investigation, being what transforms understanding of Mars' past. The findings are revolutionary, Curiosity discovering that Gale Crater contained lake billions of years ago, that water was neutral pH, not acidic, that chemistry was suitable for life, that energy sources existed, the conclusion being that ancient Mars was habitable, had conditions that could support life, whether life actually arose being unknown, but possibility being real, being scientifically credible. The organic compounds are detected, complex carbon molecules being found in sedimentary rocks, the discovery being significant, being what astrobiologists sought, being indication that Mars chemistry is complex, that building blocks of life exist, that if life arose it had necessary ingredients, the results being exciting, being what justifies continued exploration, continued search for biosignatures. The methane variations are measured, atmospheric methane levels varying seasonally, the source being mysterious, being either geological or possibly biological, the debate continuing, the mystery being what makes Mars interesting, being what keeps scientists engaged, being open question that requires more data, more investigation. Perseverance rover launches in 2020, landing in Jezero Crater in 2021, the mission being sample return precursor, collecting core samples, caching them for future retrieval mission, the long-term plan being to bring Mars samples to Earth, to analyse with full laboratory capability, to search for definitive evidence of past life, the patience being what this requires, being decade-long plan, being commitment to thorough investigation. The rover carries Ingenuity helicopter, small drone designed for technology demonstration, for proving that powered flight is possible in thin Martian atmosphere. The challenge being significant, the atmosphere being 1% of Earth's density, requiring large rotors, high speed, precise control, the flight being what nobody was certain would work. The first flight occurs in April 2021, Ingenuity hovering for 30 seconds, the achievement being historic, being first powered controlled flight on another planet, being what opens possibilities for aerial exploration, for accessing terrain rovers cannot reach, for rapid reconnaissance, the success being what encourages future missions, being what expands exploration capabilities. The helicopter continues flying, far exceeding design mission, completing dozens of flights, scouting for rover, photographing terrain, demonstrating reliability, being what proves concept, being what shows Mars can be explored from air as well as ground, the versatility being what future missions will exploit, being capability that enhances science return. The sample collection proceeds methodically, Perseverance drilling cores, analysing them, sealing them in tubes, depositing them in cache, the samples representing different rock types, different ages, different environments, the selection being careful, being what maximises science potential, being what gives Earth laboratories best chance of finding biosignatures if they exist. The story advances through these missions, through this patient accumulation of knowledge, through transformation of Mars from mystery to mapped world, from speculation to measured reality. the progression being clear, being traceable, being continuous advancement from early flybys, showing craters to orbiters revealing ancient river valleys, to landers analysing soil, to rovers driving tens of kilometres, to helicopters flying above surface, the capability growing, the understanding deepening, the Mars of 21st century being comprehensively explored world, being place we know in detail, being planet whose history we understand, whose present conditions we measure, whose future we contemplate, the exploration continuing, the missions proceeding, the patient work of revealing Mars advancing through decades of sustained effort, of careful investigation, of dedication to understanding neighbouring world that has fascinated humanity since first observation, the story being ongoing, being incomplete, being what continues advancing toward future missions, toward sample return, toward eventual human exploration, toward dreams of settlement, of making Mars home, of expanding human presence beyond Earth. The vision being what drives current exploration, being what justifies investment, being what inspires next generation. The Mars story being far from finished, being narrative that continues, that proceeds forward through time, that advances through patient scientific work, through engineering achievement, through human curiosity that persists across centuries, across millennia, the red planet calling us outward, inviting exploration, promising discovery, being world that rewards investigation with knowledge, with understanding, with revelation of its secrets gradually, patiently, through the sustained effort of missions, of spacecraft, of rovers, of orbiters, of all the robotic emissaries we send across void to touch another world, to photograph its surface, to analyse its rocks, to search for life, to understand its past, to assess its future, to make Mars known to us, to transform mystery into knowledge, the progression continuing through present toward whatever comes next. The international participation grows, Mars exploration becoming global endeavour, European Space Agency launching Mars Express orbiter in 2003, carrying Beagle 2 lander that unfortunately fails during landing, but orbiter succeeding, operating for years, mapping surface, analysing atmosphere, discovering subsurface ice deposits. The contribution being significant, being what makes Mars exploration collaborative, being shared human achievement rather than national competition. India's Mars orbiter mission, Mangalyaan, arrives in 2014, being first Asian nation to reach Mars, being achieved on first attempt, being budget mission that succeeds where many expensive missions failed, the achievement being what demonstrates that Mars exploration is accessible, is achievable, is not limited to wealthy nations, the success inspiring other countries, encouraging participation, expanding community of Mars explorers. United Arab Emirates Hope orbiter arrives in 2021, studying Martian atmosphere, weather patterns, the focus being what complements NASA and ESA missions, being different scientific goals, being what international cooperation enables, different missions addressing different questions, the whole being greater than sum of parts, the collaborative approach being what modern Mars exploration exemplifies. China's Tianwen-1 mission arrives in 2021, orbiter and Zhurong rover landing successfully, operating on surface, analysing rocks, the achievement being significant, being what makes China third nation to land successfully on Mars, being what shows Chinese space capability, being contribution to global Mars knowledge, being missions that add to comprehensive understanding. The orbital assets accumulate, multiple spacecraft circling Mars, mapping surface at various wavelengths, studying atmosphere, tracking weather, serving as communication relays for surface missions, the network being infrastructure, being what enables surface operations, being unseen support that makes rover missions possible, being foundation for future exploration. The ground-penetrating radar on orbiters reveals subsurface structure, discovering layers of ice and rock, mapping buried glaciers, finding underground water ice deposits, the hidden Mars being revealed, the subsurface being what holds secrets, being where liquid water might exist, being where life might persist if it exists. The exploration being three-dimensional, being about what lies below as much as what's visible on surface. The seasonal changes are tracked systematically, polar ice caps growing and shrinking, dust storms developing and dissipating, frost appearing and sublimating, the dynamic Mars being observed, being measured, being understood as active world, as place where processes continue, where weather happens, where seasons cycle, the monitoring being continuous, being what decades of orbital presence enables. The atmospheric studies reveal loss processes, solar wind stripping atmosphere away, the thin atmosphere being remnant of thicker ancient atmosphere, the magnetic field loss being what allowed stripping, the recognition being that Mars was protected early in history, then lost magnetic field, became vulnerable to solar wind, lost atmosphere gradually over billions of years, the understanding explaining how Mars changed from wet world to dry desert. The climate modelling uses data from missions, reconstructing ancient Mars, simulating warmer, wetter conditions, testing hypotheses about how much water existed where it went, the models being what connects observations to theory, being how scientists understand past from present evidence, being tools that reveal Mars history, that explain transformation from habitable world to harsh desert. The search for life continues being primary goal, missions designed to detect biosignatures, to find organic compounds, to identify metabolic processes, the negative results so far not proving life doesn't exist, just that it hasn't been found yet, that Mars is large planet, that limited sampling might miss rare life, that subsurface might harbour what surface lacks. The search continuing, the hope persisting, the recognition that finding life would be revolutionary, would transform understanding of biology, of life's distribution in universe. The extremophile research on Earth informs Mars exploration, organisms thriving in Earth's harshest environments, showing what's possible, microbes living in Antarctica, in deep ocean, in acidic hot springs, in radiation-intensive environments, the Earth life being what demonstrates biology's resilience, its adaptability, its ability to survive conditions previously thought impossible, the implications for Mars being obvious, being that if Earth life manages these extremes, Mars life might manage Martian conditions. The perchlorate discovery complicates life detection, Viking biology experiments possibly being compromised by reactive soil chemistry, the realization coming decades later, the recognition that Mars regolith contains oxidizing compounds that destroy organic molecules, that Viking might have found organics but destroyed them during heating, the controversy reviving, the questions being reopened, the need for new approaches being clear. The meteorite studies provide another window into Mars, rocks blasted from Mars by impacts landing on Earth, being found in Antarctica, being analysed, ALH 84001. Meteorite famously containing structures some interpret as fossil bacteria, the debate being intense, the consensus being that abiotic explanations are more likely but possibility remaining, the meteorites being actual Mars samples, being what we can study in detail on Earth, being preview of sample return missions. The technology development continues, new instruments being designed, better cameras, more sensitive spectrometers, drilling capability improving, the engineering being what enables science, being foundation for discovery, being patient work of making instruments smaller, lighter, more capable, more reliable, the progress being incremental, being continuous, being what allows each mission to do more than previous. The dust is persistent challenge, covering solar panels, degrading performance, limiting lifetime for solar-powered missions. The problem being what nuclear power solves, but at cost and complexity. The trade-offs being what mission designers navigate, being choices between different limitations, different constraints. The engineering being art of compromise, of optimizing within constraints. The communication systems evolve, data rates increasing, orbiters relaying information from surface, direct-to-Earth links being supplemented by relay capability, the bandwidth being what determines how much data returns, how many images, how detailed the analysis, the limitations being physics, being distance, being what improves with better technology but never becomes unlimited. The patience being what Mars exploration requires, the acceptance that data arrives slowly, that high-resolution images take hours to transmit, that operations proceed at measured pace. The autonomous capabilities improve, rovers making driving decisions, avoiding hazards, planning paths. The automation being what allows daily progress, being what prevents waiting for Earth commands for every action, being balance between autonomous operation and ground control, being evolution toward more capable, more independent spacecraft. The longevity improves, spirit and opportunity far exceeding design life, curiosity operating decade plus, the reliability being what engineering improvements achieve, being result of lessons learned, of better components, of redundant systems, of careful design, of extensive testing, the success being what justifies trust, being what allows ambitious missions, being foundation for future exploration. The story advances through present, the Mars exploration being ongoing endeavour, being accumulation of missions, of data, of understanding, the progress being patient, being methodical, being what decades of sustained effort achieves, the transformation from mystery to known world being complete in outline but continuing in detail, the exploration proceeding forward through time, through technology, through dedication to revealing Mars secrets, to understanding neighbouring planet, to preparing for future human presence, the narrative continuing, advancing toward whatever comes next. The evening settles over mission control, the day shift departing, night crew arriving, the transition being smooth, practiced, the continuous operations requiring constant staffing, constant vigilance, the spacecraft on Mars not caring about Earth's day-night cycle, operating on Martian time, sending data continuously, the monitoring being what mission requires, being dedication that characterizes space exploration, being patient work that continues regardless of hour, regardless of day, the commitment being total, being professional, being what makes missions successful. You find yourself standing in this quiet control room late night at JPL, watching screens displaying telemetry from rovers on Mars' surface, the data arriving with familiar delay, 20 minutes when Mars and Earth are reasonably close, longer when on opposite sides of Sun, the patience being built into operations, being accepted, being what everyone who works Mars missions understands, the impossibility of real-time control, the necessity of autonomous operation, the trust in spacecraft to handle situations, to make decisions, to continue mission even when Earth is out of contact. The current understanding of Mars is comprehensive, decades of missions revealing planet in detail, the transformation from mystery to known world being nearly complete, the broad outline being clear even as details continue emerging, the picture being one of ancient world that was once warm and wet, that had liquid water on surface, that might have been habitable, that changed dramatically as atmosphere was lost, as climate shifted, as Mars became cold desert we see today. The evidence for ancient water is overwhelming, orbital imaging showing dry river valleys, ancient lake beds, delta deposits, the features being unmistakable, being what flowing water creates, the channels winding across landscape, merging, draining into low areas, the hydrology being clear, being obvious, being proof that Mars once had precipitation, runoff, standing water, the cycle that Earth has, that makes our planet livable, that Mars lost billions of years ago. Gale crater research by Curiosity reveals detailed history, the layers of sediment being deposited in lake environment, the rocks being mudstones, siltstones, the grain sizes indicating quiet water deposition, the minerals including clays that form in presence of water, the chemistry being neutral pH, not acidic, the environment being benign, being suitable for life, being place where Earth microbes could have survived, thrived even, the ancient habitability being established, being scientific consensus, being what makes search for ancient life reasonable, justified, worth pursuing. The timeline is becoming clear, early Mars having thicker atmosphere, having magnetic field protecting it, having warmth from combination of greenhouse gases and young sun, the conditions allowing liquid water, allowing clement climate, the habitable period lasting perhaps billion years, then magnetic field failing, solar wind beginning to strip atmosphere, greenhouse effect weakening, temperatures dropping, water freezing or escaping, the transformation being gradual, being irreversible, being what left Mars as we find it, cold and dry and hostile. The water that remains is mostly frozen, polar ice caps containing substantial reserves, subsurface ice deposits being widespread, ground-penetrating radar revealing buried glaciers, frozen reservoirs, the water being there but inaccessible to surface life, being locked in ice, being unavailable for biology, for any organisms that might persist, the subsurface being where any current life would be, where liquid water might exist in deep aquifers, where geothermal heat might maintain habitable niches, the possibilities being what drive continued exploration, what justify searching. The methane mystery persists. Atmospheric measurements showing seasonal variations, the methane appearing, disappearing, the source being unknown, being either geological outgassing or possibly biological production. The debate continuing, more data being needed, the mystery being what makes Mars compelling, being open question that requires investigation, that might have profound implications if biological source is confirmed, if active life is producing methane, releasing it into atmosphere. The perchlorate problem complicates life detection, the reactive soil chemistry destroying organic compounds, the Viking results being reinterpreted, the recognition that burning soil samples might have destroyed evidence of organics, that negative results might be false negatives, that Mars might have organic chemistry that current methods cannot detect, or that methods inadvertently destroy. The challenge being what drives new approaches, new instruments, new strategies for searching. The sample return mission is planned. Mars? Sample return being joint NASA-ESA program. The architecture being complex, requiring multiple launches, rover collecting samples on Mars, fetch rover retrieving them if needed, Mars ascent vehicle launching samples into orbit, Earth return orbiter capturing them, bringing them home, the timeline being 2030s, being ambitious, being technically challenging but achievable, being what will enable definitive analysis of Mars rocks in Earth laboratories, being next major milestone in Mars exploration. The samples Perseverance is collecting are carefully chosen, representing different rock types, different ages, different depositional environments. The selection being what maximizes scientific value, being what gives best chance of finding biosignatures if they exist, the cores being sealed in tubes, being cached on surface, being what future mission will retrieve, being precious cargo, being potential evidence of life beyond Earth, being what justifies decade-long effort, enormous expense, technical complexity. The human mission planning is serious endeavour, NASA and international partners studying architectures, testing technologies, developing systems, the challenges being substantial, radiation protection during months-long journey being primary concern, the cosmic rays, solar particle events being hazards, being what requires shielding, or perhaps pharmaceutical countermeasures, being problem without perfect solution, being risk that must be managed, accepted, mitigated as much as possible. The psychological challenges are recognised: isolation, confinement, communication, delay making Earth seem distant, making crew autonomous. The mental health being what historical Antarctic expeditions illuminate, being what submarine service demonstrates, being human factors that mission design must account for, that crew selection must consider, that training must address. The recognition being that hardware alone does not ensure success, that people are a critical element, that human factors determine outcome as much as engineering. The life support systems must function for years, recycling air and water, growing food perhaps, the closed-loop systems being tested on ISS, being developed for Lunar Gateway, being refined for Mars application, the reliability being essential, being what crew life depends on, being systems that cannot fail, that must be maintainable, repairable by crew. The redundancy being built in, the spares being carried, the mission design accounting for long duration, for impossibility of rapid resupply from Earth. The landing challenge is severe, Mars' atmosphere being thick enough to require heat shield, but too thin for parachutes alone. The entry, descent and landing being what engineers call 7 minutes of terror, being phase when everything can go wrong, when spacecraft is on its own, when success or failure is determined by engineering done on Earth, by testing, by simulation, by the careful work that precedes mission, the challenge being greater for human-scale lander, being larger mass, being more critical, being what requires new technology, new approaches. The in-situ resource utilization is essential for affordability, producing propellant from Martian atmosphere, extracting water from soil, the ability to manufacture return fuel on Mars being what makes mission feasible, being what reduces launch mass from Earth, being technology that perseverance is testing, that future missions will refine, that human mission will depend upon, the demonstration being what enables architecture, what makes Mars missions practical rather than prohibitively expensive. The surface operations will be different from Moon, the day length being nearly Earth-like, the gravity being 38% of Earth's, enough to walk, to work, to function reasonably well, the suits being less bulky than lunar suits, the mobility being better, but dust being problem, perchlorates being toxic, the environment being hostile despite partial similarities to Earth, the habitats being essential, being refuge, being where crew lives between excursions, being home for years perhaps. The return journey is challenge equal to outbound, waiting for launch window, ascending from Mars, rendezvousing with Earth return vehicle, months-long coast back to Earth, the round trip being minimum 2 years, likely longer, the commitment being extraordinary, being what separates Mars mission from anything humans have attempted, being expedition not mission, being colonization precursor, not quick visit. SpaceX envisions something more ambitious, Starship being designed for Mars, Elon Musk proposing fleet of ships, establishing self-sustaining city, the vision being settlement not exploration, being transformation of Mars into second home for humanity, the timeline being aggressive, 2030s or 2040s perhaps, the skepticism being warranted but progress being real, Starship being tested, being developed, being what might enable the vision if funding continues, if technology matures, if political will persists. The challenges of settlement are even greater than exploration, sustaining population requiring agriculture, manufacturing, energy production, the infrastructure being extensive, being what must be built on Mars, using Martian resources, being bootstrapping problem, being what requires robotic precursors, what demands years of preparation, what might take decades to achieve. The vision being long-term, being multi-generational perhaps, being transformation of human civilization from single planet to multi-planet species. The ethical questions are debated, whether humans should settle Mars, whether planetary protection allows it, whether terraforming is justified, whether Mars belongs to humanity or should remain pristine. The discussions being ongoing, being unresolved, being what philosophy grapples with, what policy must eventually address, what current generation must decide for future generations. The scientific value of humans on Mars is substantial. Geologists in spacesuits accomplishing more than rovers, the direct observation, the ability to make decisions in real time, to go where interesting features are, to use intuition and experience, being what Apollo demonstrated on Moon, being what Mars exploration would gain, the science return being what justifies risk, expense, effort, being why scientists support human missions despite robotic capability. The inspiration factor is real, human missions capturing public imagination in ways robots cannot. The courage of astronauts inspiring students, driving interest in STEM, creating cultural moment, being what Apollo achieved, what Mars mission would achieve again. The intangible benefits being what makes human exploration worthwhile beyond pure science, beyond economics, being about human aspiration, about expanding horizons, about taking next step outward. The international cooperation seems likely, no single nation bearing cost alone, partnerships distributing expense and risk. The precedent being ISS, being lunar gateway, being what modern space exploration requires, being recognition that Mars mission is human achievement, not national one, that working together enables what individual nations cannot afford, cannot justify, cannot achieve alone. The timeline remains uncertain, 2030s being optimistic, 2040s being more realistic perhaps, the funding being variable, the technology development taking time, the political commitment waxing and waning, the prediction being difficult, but direction being clear, humans going to Mars being when, not if, being inevitable eventually, being next logical step after Moon, being destination that calls to us. Remember those ancient astronomers tracking Red Wanderer, wondering what it was? Now we plan to stand there, to walk its surface, to make it home perhaps, the progression being complete arc, from observation to exploration to habitation, from mystery to destination, from distant light to place we go. The transformation being what human civilization does, being expansion, being exploration, being the persistent outward movement that characterizes our species. It is very late now, the mission control being quiet, only essential personnel present, the screens glowing softly, showing data streams, telemetry from rovers that are finishing Martian day, preparing for cold night, the solar-powered systems conserving energy, the nuclear-powered Curiosity and Perseverance continuing regardless, the operations being routine now, being what happens every day, the patient work of Mars exploration proceeding while Earth sleeps. An engineer reviews latest data from Perseverance, planning tomorrow's drive, selecting target rock for analysis, uploading command sequence that rover will execute autonomously. The decisions being careful, being informed by experience, by knowledge of terrain, by scientific objectives, the planning being meticulous, being what makes every meter of progress valuable, every sample meaningful, every observation contributing to understanding. Somewhere above, Mars glows red in night sky, visible to naked eye as it has been for millennia, the same light that ancient astronomers tracked, that Lowell observed through telescope, that spacecraft now orbit and rovers explore, the constancy being what connects all eras of Mars observation, being the patient red light that has fascinated humanity across all of recorded history. The rovers rest during Martian night, conserving power, waiting for sunrise, the solar panels dormant, batteries maintaining essential systems, the patient machines being alone in alien landscape, surrounded by rocks and dust under pink sky, the cold being extreme, temperature dropping to -100 Celsius, the rovers enduring, surviving, being ready for next day's work. The orbiters continue their watch, circling Mars every few hours, cameras and instruments scanning surface, monitoring weather, tracking changes, the constant observation being what builds comprehensive understanding, being decades of patient watching, of systematic mapping, of careful measurement, the dedication being what reveals Mars, what makes it known. The story of Mars is story of patience, of careful observation, of systematic investigation, of the gradual accumulation of knowledge across millennia, from first naked eye observations to spacecraft on surface, the progression being continuous, being unbroken chain of curiosity, of wondering, of seeking to understand, the human quality being what drives exploration, what justifies effort, what makes Mars matter. The exploration continues, missions being planned, technology being developed, understanding being refined, the work proceeding patient and professional, the dedication being what characterizes space exploration, being commitment across generations, being long-term perspective that sees beyond immediate challenges, that envisions future, that works toward goals that might take decades to achieve. Rest now in this knowledge that Mars is no longer mystery, but mapped world, that we understand its history, its present, its potential future, that robots explore its surface, photograph its landscapes, analyze its rocks, that humans plan to visit, to explore, to perhaps establish presence. The story being ongoing, being incomplete, being what continues advancing through time, through technology, through human dedication to understanding, to exploring, to expanding beyond our home world. Sleep well. The rovers rest on Martian surface, solar panels folded, systems quiet, waiting for dawn. The orbiters maintain their vigil, circling ceaselessly, watching, recording. The mission controllers monitor from Earth, patient and professional. The red planet glows in night sky, same as it has for millennia, calling us outward, inviting exploration, being destination, being neighbour, being Mars. The ancient mystery becomes future home perhaps. The patient work continues. The story proceeds forward through time. Rest now. Good night. The dreams of Mars settlement persist, across decades, the vision being constant, even as details change, as technology evolves, as understanding deepens. The fundamental idea remaining that Mars can be made habitable, can be terraformed perhaps, can become second home for humanity, the ambition being extraordinary, being what drives some, what skeptics dismiss, what engineers analyse, what remains perpetual topic of discussion, debate, speculation. The terraforming concepts are studied seriously, proposals for warming Mars, for thickening atmosphere, for releasing frozen CO2, for establishing greenhouse effect, the mechanisms being various, some involving orbital mirrors, others nuclear explosions on ice caps, others slow patient release of greenhouse gases. The timescales being centuries or millennia, the effort being planetary engineering, being transformation on scale never attempted, being what current technology cannot achieve, but future technology might enable. The intermediate steps are more practical, enclosed habitats supporting small populations, gradually expanding, using local resources, building infrastructure, the progression being incremental, being what actually happens, rather than dramatic transformation, being patient work of establishing presence, proving systems, learning to live on Mars, the settlement being process not event, being decades of development, being what requires sustained commitment, sustained investment. The resources Mars offers are substantial, water ice being essential, CO2 atmosphere being convertible to oxygen and fuel, iron being abundant, silicon for solar panels, the raw materials existing, being accessible, being what enables self-sufficiency eventually, being what allows settlement to reduce dependence on Earth, to manufacture what it needs, to sustain itself, the resources being key to viability, to long-term success. The power generation is challenge, solar panels working, but being less efficient than on Earth due to distance from Sun, dust being problem, nuclear power being reliable. Alternative, the choices being what settlement must make. Balancing reliability with safety, with cost, with available technology, the energy being what enables everything else, what powers life support, manufacturing, transportation, being foundation of civilization. The agriculture experiments are conducted, growing plants in simulated Martian soil, under reduced light, in controlled environments, the success being variable, being what requires development, being learning process, the ability to grow food being essential for settlement, being what reduces resupply needs, being what makes long-term presence sustainable, the challenge being significant but solvable, being what many experiments address. The psychological research continues, analog missions in extreme environments, studying isolation effects, team dynamics, the knowledge being what informs crew selection, habitat design, mission planning, the recognition that humans need certain conditions, certain amenities, certain freedoms to maintain mental health, to function effectively, to sustain morale across years, the human factors being as important as engineering. The legal framework is undeveloped, outer space treaty, forbidding national appropriation but being silent on settlement rights, on resource extraction, on governance. The questions being unresolved, being what international law must address, being complications that become urgent as actual settlement approaches, being issues of sovereignty, jurisdiction, authority, being what peaceful settlement requires, being foundations that must be established. The cultural impact is considered. What does Mars settlement mean for humanity, for our self-concept, for our future? The philosophical questions being about expansion, about destiny, about whether humans are meant to be multi-planet species, about whether settling Mars is right or hubris, the debate being eternal, being unresolved, being what each generation must decide for itself. The children born on Mars would be different, growing up in 38% gravity, their bone structure adapting, muscle mass different. The question being whether they could visit Earth, whether the transition would be possible, whether Mars-born humans would be permanent Martians, unable to return to Earth's gravity, the medical unknowns being substantial, being what long-term settlement must address. The independence question looms. How long before Mars settlement seeks autonomy, the communication delay making real-time governance from Earth impossible, the distinct interests developing, the eventual independence being perhaps inevitable, being what history suggests, being pattern of colonies becoming nations, the timeline being generations perhaps, being when Mars population is self-sustaining, is numerous enough, is cohesive enough to govern itself. The preservation question persists. Should parts of Mars remain untouched? Should wilderness be maintained? Should scientific zones be protected? The environmental ethics being what Earth experience teaches, being mistakes we might avoid, being wisdom we might apply, being choice that current generation makes for Mars, for future, for the planet that might become home, but should perhaps remain partly pristine, partly wild, partly what it has always been. The search for life continues being priority, even as settlement is discussed, even as transformation is planned. The recognition being that finding life, even fossilized life, would be revolutionary discovery, would change everything about how we view Mars, how we approach it, whether we should settle it, the life detection being what current missions pursue, being what drives exploration, being question that must be answered before major decisions are made about Mars' future. The robotic exploration continues parallel to settlement planning, the two endeavours being complementary, robots finding resources, identifying hazards, testing technologies, the precursors being essential, being foundation for human presence, being what makes settlement possible, reduces risks, provides knowledge, the patient work of rovers and landers being what enables next step, what makes human missions feasible. The timeline convergence is possible, late 2020s and 2030s seeing both sample return and initial human missions. The decades being transformative for Mars exploration, being when speculation becomes reality, when plans become missions, when Mars becomes destination, not just study subject, the anticipation being real, being growing, being what current missions build toward. The public interest varies, some being fascinated, following missions closely, others being indifferent, seeing space exploration as luxury, as waste of resources better spent on Earth, the debate being persistent, being what all space programs face, being tension between exploration and earthly needs, between future and present, between expansion and consolidation, the balance being what societies must find, what funding decisions reflect. The inspiration of space exploration is measurable, students pursuing STEM careers citing Mars rovers, teachers using missions in curriculum, the educational value being substantial, being return on investment that exceeds pure science, being cultural benefit, being what makes societies better, what advances technology, what drives innovation, the intangible benefits being real even if difficult to quantify. The spin-off technologies are numerous. Dust removal techniques, solar panel improvements, battery advances, computer autonomy. The engineering solutions developed for Mars having Earth applications, the investment in space exploration returning dividends in unexpected ways, the innovation being what challenges produce, being benefit beyond mission objectives. The international cooperation is growing, more nations launching Mars missions, the exploration being global endeavour, being shared achievement, being what transcends national boundaries, the cooperation being what future requires, being recognition that Mars is humanity's destination, not any single nation's, being wisdom that might prevent conflict, that might unite rather than divide. The commercial sector is engaging, SpaceX being most visible, but not alone, other companies developing technologies, providing services, the private investment complementing government programs, the partnership being what enables ambitious goals, what makes rapid progress possible, what changes economics of space exploration, making it more affordable, more sustainable. The next decade will be telling, missions launching, technologies being tested, decisions being made about human missions, about sample return, about future exploration strategy, the 2030s being watershed decade perhaps, being when Mars exploration transforms, when speculation becomes capability, when dreams become plans become reality. The story of Mars exploration is far from complete, being ongoing narrative, being journey without clear endpoint, being patient progression from mystery to knowledge to presence, the arc being long, spanning millennia from first observations to current rovers to future settlements, the continuity being human curiosity, being desire to explore, to understand, to expand, being what defines us as species, being why we look at red point of light and wonder, and plan, and eventually go. The engineering challenges remain substantial, each solved problem revealing new questions, each success enabling next step, the progression being incremental, being patient work of making systems reliable, making missions achievable, making presence sustainable, the dedication being what space exploration requires, being commitment across generations, being vision that sees beyond immediate obstacles toward distant goals. The scientific questions persist, the big mysteries about past life, about current chemistry, about climate history, about water reservoirs, the answers being what continued exploration seeks, being why missions continue launching, why new instruments are developed, why sample return is priority, the knowledge being what justifies investment, being return that missions provide. The human element remains central, being why we explore, being who benefits, being species that looks outward, that wonders, that seeks to know, that cannot resist frontier, that must explore, must understand, must expand. The drive being fundamental to human nature, being what makes Mars' inevitable destination, being why spacecraft continue launching despite challenges, despite costs, despite risks. It is deepest night now, the mission control nearly empty, the essential monitoring continuing, the spacecraft functioning autonomously, the rovers sleeping or operating depending on power source, the patient machines being humanity's presence on Mars, being eyes and hands and instruments, being what extends our reach across void, being how we touch another world. An engineer makes final notes, updating mission log, documenting day's events, preparing handover to next shift. The routine being daily pattern, the dedication being professional, being what keeps missions running, what maintains the connection across 140 million miles, the patient work being what exploration is, being unglamorous dedication that achieves extraordinary results. The Mars glowing red above is same light that Babylonians tracked, that Lowell imagined canals upon, that Mariner photographed, that Vikings landed on, that rovers explore today, the constancy being profound, being what connects all eras, all observers, all explorers, the red planet being eternal presence in human consciousness, being destination that calls across ages. The future unfolds patient and inevitable. Missions will continue, rovers will drive, samples will be collected, return mission will launch, humans will eventually stand on Martian surface, looking at 2 moons in pink sky, at Earth as blue point of light, the vision being achievable, being what current work builds toward, being destination that approaches even if timeline is uncertain. The transformation from mystery to destination is nearly complete, Mars being no longer unknown world but mapped planet, being place we understand, place we prepare to visit, place that might become home, the journey being long, being patient, being what characterizes human relationship with Mars across all time, from first observation to future presence, the story being continuous, being unbroken narrative of curiosity and exploration and expansion. Rest in this knowledge that Mars is known, that rovers trace paths across its surface, that orbiters map from above, that spacecraft monitor its weather, that samples await collection, that humans plan to visit, that the red planet that fascinated ancients remains fascinating today, remains destination, remains place that calls to us, that invites exploration, that promises discovery, that offers future, the patient work continuing, the dedication persisting, the exploration proceeding through time eternal. Sleep well. The rovers rest beneath alien stars. The orbiters maintain silent watch. Mission controllers monitor from Earth. The red planet glows eternal in our sky. Ancient mystery becomes future home. The patient journey continues. The story proceeds onward through time. Mars waits, patient and persistent, close enough to see, far enough to challenge, forever calling us outward across the void. Rest now. Good night.